friends, welcome back to my channel. In this session we are discussing SSD or SSR, solid state device or solid state relay. So this 8-pin IC, its part number is R39MF51. I am using 220 volt line voltage. If you don't have a good practical experience, please never try to do this experiment or never try to deal with this voltage, because these live voltage are dangerous. Today we will discuss a very useful IC. It is R39MF5. This 8-pin IC. What is the function, how it works? When we change the frequency and the duty cycle, the output voltage are increasing. So it is working as a switch. When the frequency and duty cycle is controlled, it will control the speed of AC load, because I am providing to control AC load. What is that IC? This IC is most commonly used in the split unit indoor unit boards, where the board don't have relays for the fan speed. So this IC is used here. This IC, it receives AC voltage, line voltage, and in the output it will provide the clipped voltage, the sampled voltage. How it will sample? It will receive drive command to its input side and it will switch to output side. It is called SSD, solid state device, or SSR, solid state relay. Its part number is PR39MF51NS. And if we see on the IC, the number will R39MF5, the 1 is in the second line. It is 0.9 ampere non-zero cross type Triac Output SSD. Triac Output SSD, solid state device. It is used to control AC loads. It can provide up to 0.9 ampere RMS, the output current. The isolated interface between high voltage AC devices and low voltage control circuitry. When we are using a processor to control the voltage for any load, here I am using 220 volt AC load. If you don't have a good practical experience in power electronics, never do this experiment or never try to do this. If you see its internal structure, it is 8-pin IC, pin 1, 2, 3, 4. It is similar to optocoupler, and indeed it is optocoupler. It have IR-ED, infrared emitting diode, and IR detector here, then output Triac. Triac is used to switch AC voltage, so it is Triac based SSD. These are cathode pins. The normal signal is applied same as we apply to any optocoupler, pin 2 and 3. And then the load is connected between pin 8 and 6. Here is external gate, pin number 5. This is 8-pin IC. Pin 7 is missing. Pin 7 is not connected. I connected pin number 3 to the ground. And here I connected C945, 220 volt, 220 ohm resistance. And here I will apply signal 5 volt PWM signal. Here I am connecting a lamp between these 2 points. So it is working basically as a switch. Here it have IR LED, IR ED, and here is Triac, which is connected to detector. When it will receive signal, it will turn on this load. How it works? This is our sine signal. Because it is Triac, it will switch positive voltage and it will also switch negative voltage. when it will receive a trigger signal at any position. If we will apply a trigger pulse, if we will apply a drive pulse, from that point to next signal, it will switch in the output. If I will provide a pulse here, so it will provide this voltage in the output. If I will provide this voltage, at that time it will start switching and it will pass this pulse until the signal is not present. Main supply is clipped off. The output signal here will be disconnected. When it will receive pulse, it will provide output. When the line input will go to 0 line, it will turn off and it will wait until the next cycle. And if you will provide another pulse here in this portion, it will give the output here. If I will apply pulse here, this is the location of pulse. So at that time, from here we will receive this portion, and same way if we provide here a pulse, it will provide this voltage. If I will apply pulse at this position, at this phase angle, how we can do that? If we have any zero crossing detector that can detect that when the voltage are zero, when this zero crossing detector will detect the zero position, after that we can trigger at any point how much voltage we need. That time we will switch at that required degree. If we will trigger at 90 degree at this point, it will provide this signal. Let me increase the frequency. This time I am providing 1 Hertz 1%. (13 Hertz 1%). And if I will increase the percentage, now I am moving this pulse forth and back. 7%, 71%. We can see at 13 Hertz we have a blink, visible blink. Now if I will decrease the duty cycle, we can see the voltage are decreasing as well. Why? Because the effective value, the RMS value of that voltage will drop, because we are sampling the voltage. So in this way we can control the load. We can see at 1 Hertz we have this blink rate. At 1%, 1 Hertz 1%, there is a very little pulse arriving at the load. At 10%, 1 Hertz 10%, we have this rate. 1 Hertz 20%, this indication. Mainly it is used to control the AC loads, the inductive loads. If I will set to 50 Hertz, this time if I will decrease the duty cycle, I will receive a same pulse in each cycle at this point. We can see the very dim light is there. 2%. So I will receive a specified portion in each cycle. If I am triggering at 100%, at that time I will receive this portion. But this time I am not coincide with zero crossing. We need a zero crossing detector to take exact voltage what we need. When the cycle will start from 0, after that we will decide how much portion we need in the output. Because this time I am providing a signal at random position. I don't know it is switching here, here, here. But for exact perfect use, we need to check the zero crossing position. when it will start from 0. After that we can adjust the pulse at any position, and if I will switch at 100 Hertz, exact 100 Hertz, now we will receive pulse in positive side and negative side, and this time the RMS value will increase. Why? Because we are switching in positive and negative cycles. If we are working at 50 Hertz, that time we will take maybe in positive side or negative side pulse, but now we will receive pulse in both sides, and we can control the AC voltage to take effective work from our load. So we can control the voltage using duty cycle option. I hope this video is informative. If it is informative, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.